Hey everybody, welcome back. How's it going? So last time we pretty much finished the idea of multiple linear regression from a math point of view. Again, there's a lot more you could look at from a statistics point of view and even a machine learning point of view, which we'll definitely get to. That's the point. But from the main point of what we're doing with it to get predictions and to measure an error, we're able to do that. We're also able to get the right training parameters. So the point of machine learning is to train these parameters. And I glanced over that in this point of view, the multiple linear regression, giving you a formula that the beta vector is x transpose x, x transpose y. So even the point is that it doesn't really matter. It's just some sort of formula that arranges our parameters for us. And later on, we're going to be switching that into still using calculus, but from a much more common machine learning point of view that applies to neural networks. So we did all of this stuff, and it's hard to proceed with to implement this, and we don't have to implement it, but I'd still like to at this point. To implement multiple linear regression, we want to use this thing called NumPy. And the reason for that is because it's using a lot of linear algebra, and NumPy is really, really good at that. Linear algebra, you can think about it as doing things, multiple different parameters, multiple different inputs. Basically anything where we need vectors and matrices, this is where you're going to end up using NumPy. So in NumPy, which we can just import, it's just a library, you import it as NP like this. And so its main fundamental object is what's called the n-dimensional array. And so that could be, you could make it be either like a vector of information, like a row vector, or like a column vector, or maybe a matrix, or even something more complicated. You can think of it about as like a list of matrices, or a list of matrices. It goes on and on and on. It gets really confusing. But for the most part, for now, we're going to be sticking with vectors and matrices. So think about the list of 1, 2, 3 as, pretty much like a vector. It's pretty close. We can ask what the first, second, and third element is, except we're pretty limited with that in Python just due to its base implementation is there's not a lot of linear algebra stuff you might want to do. For example, this operation, which we haven't even discussed, kind of makes sense, right? If you add the list of 1, 2, 3 plus 5, you probably would guess that I mean you want to add 5 to this, 5 to this, and 5 to this. Or, and that will fail, by the way, that won't do anything in Python. And also something that would really make sense to you is if I was to add, say, this. Okay, if I was to add the list of 1, 1, 1, that in math would probably mean you're adding 1 here, so this 1 would go there, then the second one would add here to get 3, this one would be 4, so it'd actually be 2, 3, 4. Except in Python, well, that works, except it's actually concatenating lists. So that's why we really want NumPy. It's because if we were instead to do, if I wrap this thing in what's called NumPy array, which I'll explain very shortly, this is the main fundamental object in NumPy. So if I was to do this, well, that actually produces exactly what we'd want. It outputs it as an array of 2, 3, and 4. So it's a lot more meant for this mathy linear algebra type stuff. And so it also does all this matrix vector multiplication, which we didn't even show was matrix multiplication, and we might do that without me explaining it because it's just kind of a wasted conversation for now. So here's the main point of NumPy is to do stuff like this. And so this, we get away from the organization a little bit. Remember, we thought of normally stuff as column vectors. And so is this a column vector? Is this a row vector? I mean, in NumPy, they probably define it for you, but I'll explain when we need to care about that kind of organization of the information soon. So we have that. And just before we end this lecture, I want to show you very easily that we can make a matrix like this. And so what really is a matrix? Well, most of the time we'd think about it as a list of rows. Okay, we have row 1, row 2, row 3. And so I would actually have, here's a list, but then each element of this thing would be a list, and that would be the row. So the list of 1, 2, 3, and then outside this brackets, I'd do a comma. And then, sorry, you can't really see what I'm doing because it's popping it up. But here, so I hope this makes sense. If you think about a matrix as a list of rows, well, this whole thing we're passing is a list, and then each element of it is a row that has exactly the same amount of elements. This has 3, this has 3. And so this is a 2 by 3 matrix of exactly what it looks like, and that's going to output it exactly for us. And the final thing I want to do before we finish off is just give some intuition as to what we call the shape. Okay, so if I ask the shape of this thing, well, that gives you 2, 3. Okay, that same thing as the matrix. It's 2 by 3, 2 rows by 3 columns. And this thing, which I'll just get rid of this one for now, this thing's dot shape, which is a little bit weird. It's 3 comma, not just 3 or 3 by 1. So that's why it's pretty much a vector, and we'll get the specifics later. But you can think about this as, a 3-element vector. And so you can do vectors, matrices, you can do, list of matrices, all sorts of weird stuff with this, but we're mostly going to stick with these two, which is vectors and matrices, and we'll play around with the actual shape of this thing shortly, because I'll show you can kind of mess around with it and get a different shape like this. So this is actually 1 by 3, or you could also think about this really definitely as a column vector, if you were to think about it as a list of rows where each row only has one element. And so we could do this, 1, then 2, then 3. And so the shape of that is 3 by 1, which really definitely is a column vector. Okay, so that was a nice introduction to NumPy. We're going to get a little more used to it in the next video, and I'll see you then.